Hi, I'm Bob. Let's finish the last 7 exercises in section 9.5 today. We continue to examine the effects of government interventions such as sales tax, subsidy, price floor, and price ceiling on market equilibrium, consumer surplus, producer surplus, welfare, and deadweight laws. Let's find answers to exercise 5.11. Suppose that the demand curve for wheat is Q equals 100 minus 10 times P, and the supply curve is Q equals 10 times P. The government imposes a price support at P equals 6 using a deficiency payment program. In Part A, what is the quantity supplied, the price that clears the market, and the deficiency payment? In the textbook, we have learned 2 different types of price support programs. One is the traditional price support. The other is the deficiency payment price support. They have different effects on consumer surplus, producer surplus, and social welfare. The most prominent difference is that traditional price support causes a much larger deadweight loss than deficiency payment price support. Before trying this exercise, please compare the 2 price support programs in the textbook. This exercise is about the deficiency payment price support program. Without price support, the market equilibrium price and quantity can be found at the intersection between the demand and supply curves. Combining the demand and supply functions gives the market equilibrium price of 5 and quantity of 50. P equals 5, which is the price that clears the market. Now the price floor is binding. At the price floor of 6, producers supply a quantity of 60 units. According to the price support program, producers sell all 60 units at a price of 4 to clear the market. The government then gives the producers a deficiency payment equal to the difference between the support and actual prices, 2, times the quantity sold, 60 units. So the deficiency payment is 120. In Part B, what effect does this program have on consumer surplus, producer surplus, welfare, and deadweight laws? Without price support, the equilibrium is even. The consumer surplus is the triangle area of A plus B, which is 125. The producer surplus is the triangle area of D plus G, which is also 125. The welfare is the sum of consumer surplus and producer surplus, which is 250. With deficiency payment price support, the equilibrium is E2. The market price falls to 4, and the market quantity rises to 60. The consumer surplus is the large triangle area of A plus B plus D plus E, which is 180. The producer surplus is the triangle area of B plus C plus D plus G, which is also 180. The producer surplus includes the deficiency payment received from the government. The government deficiency payment is the rectangle area of B plus C plus D plus E plus F, which is 120. Government deficiency payments are a negative component of social welfare. social welfare is the sum of the three components above. It is 240. Compared to the case without price support, the welfare falls by 10, which is a deadweight loss to society. We can list the areas in a table. Consumers and producers benefit from the price support. The deadweight loss is the triangle wedge area of F. If the price support is the traditional one, then the deadweight loss is much larger, 110. I also calculated for comparison. Under the traditional price support at 6, the producers supply 60 units, and the consumers demand 40 units, so there is an excess supply of 20 units. The government purchases the excess supply. The deadweight loss is more than 10 times that in the deficiency payment price support program. Let's solve exercise 5.12. Suppose that the demand curve for wheat is Q equals 100 minus 10 times P, and the supply curve is Q equals 10 times P. The government imposes a price ceiling of P equals 3. In part A, describe how the equilibrium changes. The initial market equilibrium is determined by the intersection between the demand and supply curves. Combining the demand and supply functions gives the equilibrium price of 5 and quantity of 50. The price ceiling of 3 is binding. At this price, producers supply 30 units, but consumers demand 70 units. The new equilibrium is E2. The price falls from 5 to 3, and the quantity falls from 50 to 30. There is a shortage of 40 units. In part B, what effect does this ceiling have on consumer surplus, producer surplus, and deadweight loss? We can put the consumer surplus, the producer surplus, and the welfare measures in a table. Without the price ceiling, the consumer surplus is the triangle A plus B, and the producer surplus is the triangle C plus D plus E. With the price ceiling at 3, the equilibrium is E2. The producers only supply 30 units. The consumer surplus becomes the area of A plus C. The producer surplus shrinks to the area of E. The welfare reduces to the area of A plus C plus E. The deadweight loss is the triangle area of B plus D. We can calculate the values using the demand and supply functions. With the price ceiling, the consumer surplus increases by 40. The producer surplus decreases by 80, and the social welfare decreases by 40. The deadweight loss to society is 40 with the price ceiling. The reason for the deadweight loss is that at the equilibrium quantity of 30, the consumer's willingness to buy is 7, which is greater than the producer's marginal cost of 3. social welfare will increase if the equilibrium quantity increases. Let's answer exercise 5.13. The government wants to drive the price of soybeans above the equilibrium price P1 to P2. It offers growers a payment of X to reduce their output from Q1 to Q2, which is the quantity demanded by consumers at P2. Show in a figure how large X must be for growers to reduce output to this level. What are the effects of this program on consumers, farmers, and total welfare? Compare this approach to A. Offering a price support of P2, B. Offering a price support and a quota set at Q1, and C. Offering a price support and a quota set at Q2. At market equilibrium E, the producer surplus is the area of D plus E. At quantity Q2, the producer surplus is the area of B plus D. The change in producer surplus is B minus E. If this change is negative, the government should offer producers a payment of X equal to E minus B. With this payment, producers are indifferent between producing Q1 and Q2 because the producers have the same benefit. At quantity Q2, the consumer surplus reduces to the area of A. The change in consumer surplus is minus B plus C. The producer surplus has no change with the payment X. The government expense is X equals B minus E. Then the welfare change is the sum of the consumer surplus change plus the producer surplus change plus the government expense, which is minus C plus E. It is the triangle wedge area. If the government offers the traditional price support at P2, the deadweight loss will be much larger. It is the area of C plus E plus F plus G plus H. It is much larger than the deadweight loss caused by the payment of X. If the price support is the alternative type, that is the deficiency payment program, then the deadweight loss is the triangle area of H. Please return to exercise 5.11 for more information about the two types of price support programs. If the government sets a quota of Q2, then the deadweight loss is the triangle area of C plus E, which is the same as the case of payment X. We can compare the changes in consumer surplus, producer surplus, and welfare in a table. We find that the consumer surplus falls by the same amount in three cases. The producers benefit from the price support program but lose from the quota. The deadweight loss is identical in the payment and the quota cases, but becomes larger in the traditional price support case. Let's solve exercise 5.14. What were the welfare effects of the gasoline price ceiling described in Chapter 2? Add the relevant areas to a drawing like Figure 2.14. The market equilibrium is E without price control. The consumer surplus is the area A plus B plus C. The producer surplus is the area D plus E plus F. The welfare is the sum of consumer surplus and producer surplus. With the price ceiling at P bar, that is lower than the market equilibrium price, producers are willing to produce QS, but consumers want to buy QD. There is a shortage in the gasoline market. At the quantity QS, the consumer surplus is the area A plus B plus D. The producer surplus is the area of F. The welfare is A plus B plus D plus F. It decreases by the area of C plus E, which is the deadweight loss to society. We list the values in a table. The direction of the change in consumer surplus is uncertain. The consumers who can luckily buy gasoline benefit from the price ceiling. Their consumer surplus increases by the area of D. But for the consumers who no longer have a chance to buy gasoline because of the shortage, they lose. The consumer surplus falls from the area of C to 0. The producers lose because their producer surplus shrinks by D plus E. Among them, the area of D goes to consumers. For society as a whole, the price ceiling causes a deadweight loss of the triangle area of C plus E. Let's answer exercise 5.15. What are the welfare effects of a binding minimum wage? Use a graphical approach to show what happens if all workers are identical. Then describe in writing what is likely to happen to workers who differ by experience, education, age, gender, and race. In the absence of a minimum wage, the labor market equilibrium is even, where the equilibrium wage is W star and the equilibrium number of hours worked is L star. A minimum wage W underscore set above W star leads to unemployment, LS minus LD. Firms are the demand side and workers are the supply side. Without the minimum wage, the consumer surplus, or the firm surplus, is A plus B plus C. The producer surplus, or the worker surplus, is D plus E. The welfare is the sum of them. With the minimum wage, the equilibrium is E2. The firms only demand LD hours of work. The consumer surplus shrinks to A. The producer surplus is B plus D. The welfare is A plus B plus D. The deadweight loss is the triangle area of C plus E. Next, we focus on the welfare change in worker surplus. Without the minimum wage, it is D plus E. With the minimum wage, it is B plus D. It loses E but gains D. L star minus LD workers lose jobs. The remaining LD workers receive a higher wage, the minimum wage. If workers are identical, who loses jobs or getting a higher wage is random. If the workers are differentiated, those with lower marginal costs receive a higher wage, and those with higher marginal costs lose jobs. On average, the workers with better ability and education have lower marginal costs of learning skills that firms require. They are the LD workers who stay in the labor market and benefit from the minimum wage. Let's jump to exercise 5.16. A mayor wants to help renters in her city. She considers two policies that will benefit renters equally. One policy is rent control, which places a price ceiling P on rents. The other is a government housing subsidy of $S per month that lowers the amount renters pay. Who benefits and who loses from these policies? Compare the effects of these two policies on the quantity of housing consumed, consumer surplus, producer surplus, government expenditure, and deadweight loss. Does the comparison of deadweight loss depend on the elasticities of supply and demand? Without government intervention, the market equilibrium is E1, where the equilibrium price is P star and the equilibrium quantity of housing consumed is Q star. The consumer surplus is A plus B. The producer surplus is C plus D plus E. The welfare is the sum of consumer surplus and producer surplus. If the policy is rent control, the new equilibrium is E2, where the market price is P bar, and the quantity of housing consumed is QS. The consumer surplus is A plus C. The producer surplus is E. The reduction in welfare is the triangle area of B plus D, which is the deadweight loss to society. Next, we consider the subsidy policy. Suppose the subsidy is given to consumers. It shifts the demand curve to the right. The new equilibrium is E2. The equilibrium price is P tilde. Producers receive P tilde. Consumers actually pay P bar because of the subsidy of S. P bar equals the price ceiling of the first policy. In the subsidy case, the quantity of housing consumed is Q tilde, which is higher than QS of the price ceiling policy. The consumer surplus is A plus C before, but A plus B after the subsidy. We use a trick here. Notice that the triangle area of A plus B equals the triangle area of A plus C plus E plus F plus G because they have the same base and height. Thus, the change in consumer surplus is the area of E plus F plus G. On the other hand, it's obvious that the producer surplus increases by the area of C plus D. The government subsidy cost is the rectangle area C plus D plus E plus F plus G plus H. The deadweight loss is the triangle of H. Now we can compare the welfare effects of these two policies. They both lower the rent consumers pay to P bar. However, the quantity of housing consumed is higher in the subsidy case. The consumer surplus and producer surplus both rise in the subsidy case, but the producer surplus reduces in the price ceiling case. Both the two policies cause deadweight loss. Which one is bigger depends on the elasticities of the demand and supply curves. We find that the deadweight loss of the price ceiling policy is the triangle wedge, to the left of the initial equilibrium E1, and the deadweight loss of the subsidy policy is the triangle wedge to the right of the initial equilibrium. The steeper the demand curve than the supply curve, the smaller the deadweight loss of the subsidy policy than the price ceiling policy. In other words, if the demand for housing is very inelastic, which is often the case in the short run, then the subsidy policy leads to less deadweight loss. Let's finish the last exercise in this section. Draw and label a figure to illustrate the effects of a price control in the natural gas market as described in the application The Social Cost of a Natural Gas Price Ceiling. The price ceiling of P bar causes the equilibrium quantity to reduce from Q star to Qs. The deadweight loss is the triangle area of A plus B, which is $10.5 billion per year, according to the estimates in the application. In addition to this deadweight loss, there is an allocative cost that is not on the graph. The shortage of natural gas causes the allocative cost. Consumers have to spend time searching for gas, and those who get the gas may not be the ones who value the gas most. The estimate of the allocative cost is $3.6 billion according to the textbook. Therefore, the total loss is $14.1 billion per year. The deadweight loss underestimates the true loss of the price ceiling policy. Thank you very much for solving all the exercises with me today. See you soon in the next section of this chapter. Goodbye. Thank you for watching this video and subscribing to my YouTube channel. See you next time.